and emerging. Thank you so much for coming today. For those of you who don't know, this is SYNCS, the Sydney Computing Society. In specific, this is a tech event. So throughout the semester, we run tech events like tech talks, like the one today. We also run programming competitions, workshops, things to help you upskill in your journey to become researchers, software engineers, or whatever field you may want to progress in. Okay. Without further ado, I'm really excited to present to you today. Ethan Trang, please give a round of applause.
I'm actually really nervous, so hopefully it goes well.
Don't close this.
Alright, just want to say thank you everyone for coming to attend this tech talk today. I'm Ethan, and just from the title, I'm going to be sharing a very popular AI technology, or you could say framework, that's been very popular. And ultimately, I just want to show that getting into AI engineering is quite an accessible field to get into. And just like through the demonstration today, I just want to enlighten a bit more about the AI industry and how new developers can get into AI engineering. All right. Just before I start, I'm just going to put this QR code up. It's a Google form, so if you have any questions, just pop it in. And if I don't look at the Google form, please yell at my face, and then I'll come back and look at the questions. All right. Right, so I'm just going to move over. I'm Ethan. I'm a first-year software engineering student here at university. And just to speak a little bit about my AI experience. Back in Vietnam, I was an AI engineering intern for VNG Corporation, which is Vietnam's technology unicorn. There I was working on enterprise-grade AI software. Also, I was doing market research and sales for Reno, which is a cloud service provider that's partnered with NVIDIA. So more on them later. But basically, we're selling sort of like GPU to the cloud to regions in Southeast Asia. And currently today, I'm also the co-founder of Dora AI, along with Pete. Everyone say hi to Pete.
Hi, Pete.
Hi. And we're an AI educational tool to help you generate flashcards, quizzes, and notes from files, videos, websites, etc. Without further ado, I'll just jump straight in. So, speaking about AI, I'm just going to start with the page that most people are familiar with. It's the page that you open when your assignment's due in 3 hours, and it's your last resort. It's a very common page that people resort to. But just through talking with a lot of people who have used AI, it's funny that most people start on this page but ultimately feel disappointed and just stop using ChatGPT altogether. And one of the main reasons why I think, and sort of I've seen that most people get disappointed, is because the responses aren't context specific enough. It doesn't really know about what you're talking about or what you want to ask it. Maybe the format's not right either. And also the voice of the text is very robotic. So just to illuminate that a bit more, I'm just going to do an example here. I'm going to say, write me an application to SYNCS. I do not condone this. This is only for examples. And just going to say, it's just going to give it a bit more context, which is the Computing Society at. So it's already taken like the approach of a cover letter, which is in contrast to how SYNCS is usually through a Google form. It actually doesn't know like the SYNCS application questions as it's running right now. The other thing is that it doesn't know the specific details of what SYNCS really is. It doesn't know that we have awesome tech events coordinators. It doesn't know that we run like programming events, etc. It's not really up to date with information. So through those, we've already shown that first, ChatGPT isn't context specific. It's also not format specific. And just to pop in another question, let's say, who is the Prime Minister of Australia? You can see there's also like a big context cut off based on its training data. So it's only updated to January 2022. So just tabbing over here again, the main thing that most people are disappointed with AI is that it can't deliver context-specific and format-specific responses consistently. And it cannot stay up to date with new information. So why is it that such a massive engineering feat like ChatGPT tends to disappoint most people? And the interesting thing that ties straight into what this tech talk is about. It's about RAGs, which stands for Retrieval Augmented Generation. It's a very scary term, but we'll elaborate on it in a bit. But I just want to show you just a sneak peek about AI tools that leverage this technology called RAGs, and just to see how they can sort of circumvent the pitfalls that I demonstrated with ChatGPT just now. So I'm just going to open up these apps right now. Does anyone know about Perplexity? Small person. Might be a game changer for you. So Perplexity is an app that's trying to rival against Google, and is trying to use very relevant sources to answer questions. So I'm going to ask the same question I did before. Who is the Prime Minister of Australia? I'm just going to make this a bit bigger. And it's answered with Anthony Albanese. I'm not a local here, so hopefully locals can verify that it's correct. But you can see that very slightly, this is going to hit at a few insights for RAGs right here. It's actually using government websites, it's using Wikipedia, it's using news as well to get the right context to answer this question. Another tool that I'd like to demonstrate is Sonnet. So Sonnet is an end-to-end meeting assistant, quite a big turn from what Perplexity is. But I'm just going to pull up an example here. And so this is their application for MacBook. I'm just going to select this meeting. So I turned on Sonnet during my meeting, and it's basically a summarizing tool that helps you generate notes and sort of like key actions for your meetings. Let me drag this up a bit here. So what's very cool is that you can actually set the format that you want for Sonnet. You can actually create your own template, and then Sonnet's going to transcribe your meeting and actually input it into this format. So this is another application of how we can overcome the fact that we can actually preset the exact format that we want for our AI applications. And just a few more examples here. But yeah. And finally, just a quick showcase of Dore AI, which is the tool that I'm currently working on. It's an educational tool that essentially helps you create flashcards, quizzes, and notes from basically anything. So files, videos, websites. I'm just going to do an example with a website here. And then I'm just going to do how to, what are RAGs? Let's say. And I'm just going to pop the URL in here. But I'm just going to tab back over as that's generating. And just to speak a bit more about why RAGs continues to be a very effective solution to the pitfalls that I mentioned before with ChatGPT. So RAGs stand for Retrieval Augmented Generation. And RAGs combat, like I said, like the pitfalls of just using plain AI models, just like we did before at the beginning. And ultimately, I just want to show that how new developers can actually create the applications, similar forms of the applications before, in order to improve using AI in our workflows. And hopefully, if we tap over, it's already generating a bit of content based on the medium article code that we put in here. So all these are examples of RAGs, and ultimately I just want to show a bit more about the process, so we're going to go through a code demonstration later. But just before we do that, I actually wanted to step back a bit and just take a look at the whole industry as a whole. So this is just to sort of inform on how we as new developers fit into this entire industry and how we've gotten here in the first place. Why are these RAG applications so popular now? And ultimately, like wanting to sort of convince you to actually try it out yourself. So this is going to be like my bottom-up or layered approach to explaining the AI industry. Disclaimer: I'm not an expert. I'm just really like enthusiastic about AI, and just sort of sharing a bit about like my experience before working in the industry. All right. But before I do that, any questions so far, or any questions that were put in before? All right. So at the foundation of the AI industry, we have hardware. So hardware refers to basically the bare metal, the actual silicon that powers, that provides the computing power to fine-tune models, and ultimately also to scale these applications to users all around the world. And hardware companies that are examples of this include NVIDIA, AMD, and Intel. NVIDIA beating like the other two by a large margin, and NVIDIA actually experiencing one of the biggest successes in this current AI wave. This year, at one point, NVIDIA was ranked as the second largest company in the world with a $2 trillion market cap, despite not many people knowing what NVIDIA is. And it's simply because they're at the foundation that everyone has to rely on. That's why they get sort of like the biggest piece of the pie. Speaking more to who these hardware companies sell to, they sell to primarily two sorts of customers. First are the companies that will buy their physical chips and sort of like host their own data centers. These companies include Google, they include Microsoft. They'll actually buy the chips from NVIDIA and sort of like train their own models or also like serve their applications as well. And the other subset are cloud service providers, also including Google, AWS, Azure. But although this industry of cloud service providing has been for a long time an industry that's been dominated by a few players, due to the immense like competition, there's been like the emergence of smaller firms such as CoreWeave, Greenode, and Lambda Labs as well. So this is sort of to show a bit more of like how the mere foundation of AI is growing and how it's very important to consider because with all the capital and all the physical resources that are needed for AI computing. A bit more of like the price, which I find really interesting, is that because of such high demand and low supply of these things, NVIDIA chips, like their cutting edge chips, can go for 10 to 20K per chip. And for regions that are more restricted to get access to this, parallel markets can sell them up to 70K to 100K per chip. So it's sort of speaking to like the immense demand and like sort of the core need to have these chips in order to train AI models. Quick side note, that's sort of like the picture on the top there. So NVIDIA actually does most of the designs and like the research to build these chips, but the actual manufacturing occurs in Taiwan. It's led by the Taiwanese semiconductor company, TSMC, and they've sort of like piggybacked off NVIDIA's success and also reaching around like the top 15 largest companies in the world as well. And the final note that I wanted to mention is a bit on like the importance of politics and geography when it comes to this thing, which is a bit of a weird connection. So Greenode, which is the cloud service provider that I used to work at, was just formed in December of last year. And it was an emergence because the US had banned NVIDIA to sell their AI chips to the Middle East and China. And the reason being probably because they don't want China and the Middle East to catch up in this AI race, sort of like restricting access to them. So this actually opened up a lot of opportunities for countries in the Southeast Asian region to partner with NVIDIA, get their chips, and sell the computing power to these companies to the cloud. And that's specifically what Greenode does. Speaking to geography, it's simply the distance between where the server is and where the companies are using. It's just because like the data transfer between the company and the server needs to be fast because we're working with like quite large scale when you're training AI models. So the distance between, so that's why like Southeast Asia has like had a big advantage in being very close to countries in high demand such as the Middle East and China. And that's sort of speaking to how this cloud and GPU market has been changing since. That's it for hardware. And moving up a level, I want to show this kind of comic, which I think is really funny. This says, when everyone digs for gold, sell shovels. And just speaking to the idea that NVIDIA is sort of the person selling shovels. They are the pure resources that are needed in order for big companies like Microsoft, Google, and Meta to actually train these models in the first place. Right. So now moving on to foundational models, and I think this is where the most people will be most familiar with. Companies like OpenAI, you might have heard of Anthropic, Cohere, Mistral. All these are companies that focus heavily on developing AI models, and that's their sole product. We've also seen popular, like more general tech companies like Google, Microsoft, and Meta finally coming in to build their own models themselves. So Google has Gemini, Microsoft technically doesn't train their models, but they own GitHub Copilot, and Meta has Llama as well. So we sort of seen this rapid shift and sort of like rapid innovation when it comes to the AI space. Google actually having to iterate a lot and sort of experimenting and changing up their models. We've seen, you might have heard in the news like how Bard sort of failed, or recently I think the Gemini model producing weird pictures or like of the sort. So that's sort of how these foundational models have really captured the attention of even big players that have sort of stood for like for a long time, like Google and Microsoft. And it's just really exciting to see that how all this hype surrounding AI has forced a lot of big players to continue innovating and improving these models. Which ultimately leads us to the question, like, how did we get here in the first place? So the biggest sort of AI hype came from when ChatGPT was released. ChatGPT, but before I speak about that, I want to take us back to 2017 when Google Research released a paper called "Attention is All You Need," and in that paper they detailed something called the transformer architecture, and this is the technology that underlies generative AI models. So AI models previously were more reliant on traditional linear regression, logistic regression, supervised machine learning practices, but the introduction of the transformer allowed for more novel generation, if that makes sense. So transformers is the T in ChatGPT. So GPT stands for Generative Pre-trained Transformer. And basically what generative models differ is that they are more in terms of predicting the next word. So how old foundational models like GPT-2 worked is that you would put half a sentence and they would try to fill the remainder of the sentence in a meaningful way. So this is sort of the generative element of these models. But the major pivot that OpenAI's ChatGPT did is that they had a very user-centered design. And this is through the question and answer interface. You would ask a question to ChatGPT, it would understand the question, and sort of give you a response that immediately, in more general terms, targets what you wanted it to do. And that made it very accessible to practically everyone. You didn't know how to code. You didn't need to set up and pull the model yourself. You could just go to the website, type in a question. You just know natural language, then it just helped make ChatGPT very accessible to everyone and sort of show the immense power that it had. And ChatGPT, I've said ChatGPT so many times today. ChatGPT is the fastest ever growing app, reaching 1 million users in around 5 days. And that was sort of the big tipping point that the whole world had to really focus in and pay attention to this. Quick side note, just talking a bit on sort of the investing and marketing side as well. So investors and marketers play a big role in sort of the economy as well. And I just wanted to tap over to this website. So Y Combinator is a venture capital firm, a startup school that is pouring money into a lot of AI apps recently. So that's not loading as I wanted to. There we go. So this was their most recent batch. And I'm just going to scroll over, make this a bit bigger. But you can just see such a disproportionate amount of these companies being AI-related companies. And in fact, a lot of these AI companies leverage RAGs as well, which just sort of speaks a bit more to the importance of this technology. So yeah, that's a quick side note there. And the other interesting thing is that marketers and influencers have a lot of leverage when it comes to this economy as well, just because their audience makes them so visible. Sort of like Instagram influencers, like this one I showed up here, are student influencers that might show study-related AI apps as well. So it just sort of speaks to the two main components of leverage you have in the economy. One is capital, and the other is sort of having an audience and producing content that people like. Which ultimately leads us to, okay, now what? I sort of talked about hardware companies, foundational models, investors, and marketers. And I think most of us might not resonate a lot with those. Hardware is incredibly difficult to design and produce. I don't even need to stress how much hard it is to train AI models or fine-tune AI models. And not everyone has money like YC. Not everyone has money like YC, or has the sort of audience and influence that influencers do. So it sort of centers back to where we fit into the picture, where we are new developers wanting to get a little piece of this AI hype, and it's sort of how do we get started, right? We've seen a rapid emergence of new products that leverage the lower layers that I talked about, so hardware and foundational models, right? And RAG technology is the same technology that powers the products that I mentioned before. So Perplexity, Sonnet, and Dory AI are leveraging some form of this framework of RAGs. Hopefully that will be a bit more crystallized when I show it later. And these RAG companies have achieved immense success. So we can just look at Perplexity's valuation, which I believe is around $1 billion. There's another company called Zapier, which does AI integration, which is valued at, $5 billion. And there's also like apps like Glee, which are like enterprise search software, and that's valued at $2 billion. So this is an industry that I think most people, an application that most people haven't heard of, but it's an incredibly lucrative industry. And honestly, which goes back to my point, very easy to just get started and to understand how it works. Without further ado, I think it's best to just jump straight into the code. You guys can open your laptops and follow along if you want. But this is just going to be like very much code-like, and it's just to illustrate like how you can start coding your first RAG by the end of the session. All right, and the thing that we'll be coding is going to be an info chatbot. But sorry, just before I get started with this, any questions so far, or any questions in the forum? Okay, I'm good. So I'm just going to open up my code really quick. Scroll up here to the top. Does everyone see that okay? All right. Okay, so initially just the setup. Maybe you guys might not be able to set this up right now, but just head to platform.openai.com. This is the developer page where you can get your API key. And the API key is basically just like a string, like a password that allows you to access OpenAI models inside your code. So go here, get your API key set up. I'm not going to show that because it's private. Please don't steal my keys. But yeah, and you'll have to pay for these for credits as well. I paid around $20. I haven't even finished it, and I've been using it for around 5 months or so. So I don't think it's a big investment here just to get started. Set up a new directory. Set up an .nv. If that helps. Cool. So we'll also need to install some packages. I've just included here in requirements.txt. You just download the OpenAI here, and that's using like pip install, like inside the terminal. Just do pip. Sorry, let me activate my environment really quick. Okay, and that's just pip install OpenAI, and that should do the trick. Cool. So I'm just going to import the modules in here, OpenAI, OS, .env, and this part is just to get the OpenAI key from my NV file here. And I'm also going to set up the client like this. So just client equals OpenAI. So this will lead us into the first building block when it comes to building your first RAG application. And those are chat completions. So chat completions are basically what you do in ChatGPT, but inside of code. So you'll set up a client, and this code snippet here you can get from the API reference. You can just search OpenAI API reference, and I'm just going to show where you can find it. You go to chat. Hopefully I can show it right here. And yeah, I just copied the code snippet from here. Cool. I'm going to go back here. And basically what you can do is like you will set up a system message and a user message, more on the system message in a bit. And then I'm just going to, I already wrote a prompt here to write me a haiku about computers. You can also choose the model as well. So I just set it to GPT 3.5/turbo, -turbo. And this is just the basic ChatGPT model. The system message here sort of refers to the personality of the AI that you're using. So the standard one is just to say you're a helpful assistant. And then I'm just going to run this right now. Oops, I did not run this piece. Right, cool. So it's just wrote us a haiku here. And just to illustrate a bit more about the system message, you could do something where you always reply in capital letters. And you can just run it again. And hopefully it sort of demonstrates what the system message sort of like generally applies to all the messages that you put into the AI. So it's basically made a new haiku, but just did it all in capital letters this time. This is something that you could tweak as well. A bit more in depth at how this thing can work. There's also something in AI models called temperature. So temperature is a scale from 0 to 1, and it sort of controls the deterministicness of the AI model. So a temperature of 0 is like a very cold and like straightforward type of AI. whereas like a temperature of 1 is more creative. It's more good for like creative applications like writing an essay, generating ideas, brainstorming, etc. So generally, I just like to set it at 0, but in this case, I don't think it will make much of a difference. But yeah. Any questions on this so far, just on chat completions? So it's just setting up the client using the create function, and honestly, it's just best to use the API reference to just generate your first chat completion. Cool. The second building block is embeddings, and I hope this is like a new concept because it's very specific to RAGs. So embedding models, which are created like by companies like OpenAI, they produce vector representations from pure text. It's basically having a paragraph of text, feeding it to the model, and it'll give you a vector of like floating point numbers. And I just wanted to use this sort of image to sort of like explain how these embedding vectors are useful. So just taking a look at that graph over there, hopefully you're picking up on a few patterns. Does anyone want to share their thoughts on that?
They are separated by similarity.
Yeah, so you can see like, for coffee, tea, and lemonade, they sort of fall under the general category of beverages, right? Ship, car, bike, those are vehicles. Salad, stew, and slightly fish, those are like food items. And like fish, wolf, and bear, which are like animals. So the embedding model has been trained in a way such that its vector, which is sort of like this point in space, that's text that is similar to it, will be very close to each other in this vector space. And that's sort of illustrated here in this two-dimensional model. So to find sort of like the closeness of two paragraphs of text, you can turn them both into embeddings, and then compare their embeddings using cosine similarity. You can even do like the Euclidean distance, so it's just the pure distance between the two vectors in space. There's also dot product, but generally you'll use something called cosine similarity, which spans from 0 to 1. And that's sort of like illustrated here. So the closer the angles between the two vectors are, the closer they are in meaning. And that's how you sort of like search for very relevant text, which we'll see later. Any questions on embeddings? Good? All right. So now we're going to go straight into the process of building the RAG. So we've had our two building blocks, which are chat completions and vector embeddings. Oh, I sort of defined the cosine. I'll just show embeddings here. So this is the text that I put in here. OpenAI's embedding model is called Ada, and then I'm just going to run this here. It won't be very interesting because it'll just be like a humongous string of numbers. This vector by OpenAI is 1,536 dimensions, which doesn't mean a lot in like physical space, but in this imaginary vector space, it helps us find similarity. I've sort of created this, and this is just the function to calculate cosine similarity here. So I'm just going to define that. So I've created a bit of a mock database here to sort of show like how we can find the most relevant text using vector embeddings. So I'm Vietnamese, I like dogs. Morris is the tech events coordinator and is very tall, as you can see. I've added Tommy here as well. He's the tech events director as well, likes basketball. And Sinks is the computing club at UCID. And this is just a dictionary containing like the text here. No questions here, right? This is just set up. So for each item in this database, I'm just going to loop through each item in this database right now. And I'm going to use the same embedding code snippet before to generate an embedding for each of these texts and put them into the vector database. So I'm just going to run this here. You can see like the first item, this is the text that I wrote in the first line here, and that's its subsequent embedding. I probably couldn't scroll through all of this, but hopefully you get the point there. And that's through the initial process for RAGs, which is ingestion and creating a vector database. So with most applications, you'll have like a ton of data. Like companies have a ton of data, like HR documents, finance documents. Students have a lot of data, slides, websites, videos. And it's too much for AI to consume at a time. You probably like chucked in writing. So sort of the anatomy of a vector DB, as we've seen in our mock database so far, Generally, each row contains some text and its subsequent embedding, and some form of ID as well. So these are just some popular apps that you can use to get started. You don't even need to do like the database yourself. You can just look at the docs. But I just wanted to show how these vector databases work under the hood. So this leads us to the process of how do we get the most relevant information given our vector database. And to do that, we're going to use embeddings as well. So I'm going to test it with a question: what is the name of UCIT's computing society? And I tested this with ChatGPT, and the answer kind of sucks. It literally sucks. Sucks. All right. So hopefully, with our new RAG application, we're going to try to overcome this and help ChatGPT actually answer this question correctly using our vector database. So I've defined the question in a variable here. What is the name of the UCIT Computing Society? And I'm going to create an embedding for this specific question. All right. So I didn't print it out, so that was a terrible demonstration. But basically, this question embedding variable now contains the vector that represents the meaning, the semantics of the question: what is the name of the UCIT Computing Society? Now, any guesses on to how we're going to search for the best one and sort of help us answer this question? Any guesses? Or should we just walk through it? So we already know that our vector database contains all of the embeddings for all the text in here. And we know that in this database, we have the information that is needed to answer the question. So based on this so far, right, we're going to use the cosine similarity function that we defined before. And we're going to calculate the cosine similarity. So that is sort of like the angle between the question embedding vector and all the other vectors that we defined in our vector database. Does that make sense? So I'm going to run that here. And so for item in database, I'm going to create a new column, basically, and I'm going to tie that similarity. And that's going to be equal to the cosine similarity between my question embedding here and the embedding of that row in the database. And I'm going to print this database out, and hopefully we'll get some insight here. All right, and it's also sorted in order as well. So you can see that the text sinks is the computing club at UCIT turned out on top, because the term computing club at UCIT was also used in the question of the embedding that we made before. So it's very likely that those embedding vectors would be closer. And that's why the cosine similarity of 0.87 basically refers to the fact that those vectors are very close in this space. And that turned out to be the highest one as well. Scrolling down, we can see that Morris is a tech events director, and also like Tommy's line is also like higher ranked than the last one. And it's likely because tech events sort of relates to computing, right? And therefore this vector, this specific vector embedding would be closer to the question embedding as well. And my one, which has nothing related to computing at all, like being Vietnamese and liking dogs, has the lowest score. Essentially, we'll run this sort of like function to find the cosine similarity between the vector, the question embedding, and all the embeddings in our database, and we just select the top ones to put as sort of context for ChatGPT to answer. So it's just scrolling over here. So this is sort of like the query embedding process. So I embed the question, I do the similarity search, and then I rank it, so by sorting. And I retrieve the two sort of like highest, or like the top like result in this answer, in this example. So the final step is just output generation. And it's basically doing a format string where you take the text that you search for, which is the highest score, you put it on top, and then you put the question originally at the bottom. And then you throw that whole piece into ChatGPT. It's the same thing as doing like this. It's the same thing as taking this piece, putting it here, and then asking the question like this. And hopefully this visualizes a little bit better. So in this case, oh, what is happening?
Yo.
Anyways,
Can we read
this is
that?
why. This is
Yo, let's read that.
This is why you don't use ChatGPT. but okay. Based on that, we're gonna see how our RAG application which has only been like 12 blocks so far. See how that performs. So we took the database text here, which is basically our new database that's been re-ranked. Is going to take this line. It's going to put our question. Now I'm like very, very scared of what's going to happen, but we're going to run it here. Hopefully it doesn't like hallucinate or anything. But yeah, so that's sort of like our major success here. So we've had the initial problem of ChatGPT throwing some crazy responses on what uses computing society is, but to now actually taking a lot of data, searching for the most relevant one, and then using it to answer very application or very like context-specific questions. And hopefully you'll sort of recognize the big power here of what RAGS does. I can already see like Morris taking a photo of that, which is really funny. And that sort of concludes a bit of like what this code demonstration is about. Just to show you in a very short code snippet how we've effectively enhanced what OpenAI can do by itself by adding our data, our sort of processes in order to enhance like the responses. So it's basically prompt formatting. So this is the A in RAG, which is augmenting, which means to improve. And then you'll just put that whole message, and then you'll just generate it with the model of your choice. Another extension on top of this, which I hadn't coded out, is that you can actually also force the output using temperature, or you can also force it in like the JSON format. So temperature, as I said before, is if you set the temperature lower, it's going to be very deterministic. It's going to show you the same output. If you run it like the same message like 10 times, it's going to show you the same output. The thing about generative models is that even if you put the question and you set the temperature high, it might generate a different response every single time. And that's sort of like the interesting thing about AI models. The other thing is you can also format it in JSON. So basically that's like, for example, you had, let's say, let me think of a good example for this. But the main like value of, you can actually force like the data types that AI produces. So let's say you have like a spreadsheet, and like the spreadsheet has like a row of names, a row of emails, and like the ages of those people, right? That could be data that you feed into ChatGPT, and there's docs on this which are a bit more like higher in terms of like the scope that I want to cover in this tech talk. But you can actually ask it to look at the data and format it, find the number, and actually return that as an integer inside a JSON object, which is like a dictionary. So based on that, you can actually use AI to create the parameters for your functions, and it can do that all by itself, all autonomously. And that falls under the thing called tools and agents. I'm just going to show a quick snippet of what that looks like. LangChain agents. So LangChain is the library that you should go to if you want to dive into this deeper. This is bad. I did not go this through. This is all okay. So basically here, you can just see like this is actually the output that ChatGPT generated if you decide to force it the JSON output. And this thing can be reformatted into like a dictionary in Python, and then you can extract those variables and then write your own functions. So what people have liked to do with like AI agents is that generally like ChatGPT is very bad at math. If you can like put in your math prompts, it's likely going to make some errors just because it's a very text-based model. What people have done is that they've created like these agents that will take the sort of the numbers from your question and then will run a separate function that's like very well defined. So the only role in the AI is to find out what the problem is, get the parameters, and then put it into your defined functions, and then that will produce a correct response every single time. So this is sort of like increasing more on the layers of what RAGs can actually get to. And that's very powerful. Just that you can actually force certain things out of AI that most people, that on ChatGPT, where you can't change the temperature, you can't change the system message, that's very hard to do here. And that's why there's a lot of value in learning how to code a RAG application by yourself. All right, quick summary. There's 3 processes to RAG. There's ingestion. So that's the part where you have this big chunk of data, then you sort of like slice it all up. So I slice it up into like sentences. and then I embedded each of those chunks, and then I put them into my vector database, which in this example was just a list. The second process is retrieval, where you'll have a query, like a question. You embed that question. Then you use that embedding to search it against the entire vector database. And that will sort of retrieve the most relevant chunks, the top two chunks, the top one or two chunks that you can use in the generation process. And generation is simply just taking the text, putting your question, and then putting it into ChatGPT. And that's sort of like a big summary on like the processes so far. Is there any questions at all? Yes.
Is there any way to fine-tune like the vectorization process?
How would you want to, what is?
Like for example, you gave an example where you gave a sentence, like Sinks is the Sydney Computing Society, and then like another sentence, and it generated a vector, like a vector for those two sentences. Let's say you take the cosine between those two vectors, and let's say you think, oh, this is pretty far apart, but I'd actually like to be close together. Is there any way to like fine-tune how it decides how those vectors are formed?
So these models are just like, they're just like AI models, so anyone can fine-tune an AI model if it's open source. So there's a lot of open source embedding models as well. And it's very interesting that an OpenAI's embedding model won't work well with like Vietnamese text or Chinese text, just because it's been trained mostly on like English text. So that's how it's understood meaning. So there's like open source models that people have fine-tuned and created that are very specific to a certain language, and that they will better capture the meaning between two paragraphs in that specific language. And hopefully that answers your question. So these embedding models just act like AI models as well. The only difference is that their output is a vector instead of text. Yeah.
There's a question.
Yeah, sorry.
How do embedding models handle a string of like different sizes?
So the most powerful thing about embedding models is you can put one word into an embedding model, and you can put like 1,000 words into an embedding model, but the output will always be 1,536 dimensions. So the way that people have trained embedding models is that initially it's hard to visualize. We can imagine like 3 columns, right? There's like the first column where there's all your training data full of text. Then it's going to be put into a model that is going to try and generate floating point numbers as its result. Then they'll try to decode that and compare it with the initial text. Are they actually close to each other? So they just do that a bunch of times, such that the model kind of has like this idea of what meaning and semantics actually is. So hopefully I avoided your question a little bit, but embedding models are basically trying to represent like meaning, but in a very like quantifiable way, so that you can do like semantic similarity search with it. All right. That actually leads me to sort of like the end of the tech talk. I have this repository for the code that I've used just now. I'll share the slides in a bit. Just a brief run through of like more about how you can get started with RAGs. There's a bunch of models. You don't need to use ChatGPT. You can use Google's Gemini. You can use Anthropic, Claude. The libraries that you can get started with for both JavaScript and Python, which is more popular for AI applications, are LangChain, and you can use like the OpenAI API reference. Vector databases, Chroma, Pinecone, Redis, Quadrant. Pinecone's paid, Quadrant's also paid, so I recommend getting started with like Chroma or something. YouTube channels, James Briggs is where I learned most of this stuff. He's very good. He works at Pinecone, so he really knows his stuff. And yeah, and other stuff you'll need if you actually want to make this into an app, like APIs and deployment. And the final thing you'll need is an awesome problem to solve. So hopefully the initial RAG applications that I showed at the beginning serve as a source of inspiration for you to solve your own problems. So AI, Perplexity, and Sonnet. I'm not sure if I'll cover this stuff, but if there's any questions specifically overall about the RAGs, and maybe like just curious questions on if you have any ideas that you want to validate to see if like RAGs will work in that context, I'm happy to walk through that as well. But this is sort of just more like free flow Q&A on like just talking about these applications. Yes.
Sorry. So is it so that ChatGPT doesn't use RAGs, but you can leverage ChatGPT's APIs in your RAGs?
Yeah. Yeah. So foundational models like ChatGPT, Claude, etc., are made to be as general as possible. Their main like value here is not like so RAGs doesn't diminish the value of foundational models, because foundational models are very good at generating meaningful text that people can actually read. It actually makes sense. The main pitfall that just using a bare AI model is that it doesn't have the context that you want it to have, or doesn't have the format that you want it to do. By actually bringing it into your code with the API, allows you to set more parameters and sort of fix it into the way that exactly how you want it to work. That's sort of like the value of RAGs. Yes.
What's one way that you've used RAGs in your startup?
Oh, okay. So let's just tap over to Dory maybe.
Not an ad, by the way.
Not an ad.
Not an ad.
Not an ad.
We do not endorse this. So just now I put in a website, right? So what is the example of, okay, let's go back to the slide here, right? Did everyone see like the sort of demo with the website and stuff? So I'll just run through it very quickly again. Basically, I put in a Medium article, like from like a website, and then I put it into Dory, and it's generating flashcards for me. So we're going to go back to this example here. So what is the element, what's the big data here that we're trying to sort of like slim down and find the most relevant chunks from?
The
It's
website.
sorry?
The website.
Yeah, the entire text of the website, right? Maybe that text could fit into ChatGPT, but if you're working with like a really long PDF, then maybe that's not feasible. Also, it's very annoying to copy text and then paste it back and forth all the time. So that's actually the initial step, of just getting like the text. Then you would like chunk it up, you embed it, and then the same process happens again, where in this case the query, we do something quite different at Dory, which is a bit harder to explain. But essentially, we're just going through the chunks, getting the text, and generating flashcards like that. So it's going through the website top down, slowly, and then using the text to create the flashcards. So it's using very context-specific data. So, apply to the example of like a slides. Maybe like your teacher might define this term in a certain way, and they might want you to use that exact way of explaining in your exam, right? So in that case, you could actually, that's where context-specific becomes very helpful, because it's actually just not using general terms. It's using the exact thing that you want it to do, and that you want it to output. So that's sort of like another like insight and advantage to having very context-specific data. So it's just a matter of like finding where all the data is, like this sort of general theme of data, how you can like slice it up, and then implement this whole process: ingestion, retrieval, and generate. And hopefully, like maybe the student example is the easiest to visualize, and that's sort of like the app that Dory AI is focused on as well. But essentially, it's just finding where a lot of data lies and how AI can optimize that, right? All of this is just, I like to use the motto: familiar inputs and useful outputs. So find where text and data is very familiar to you, like where are these familiar sources of data that you get, and how can you use the RAG framework and to generate it into something that's a useful output. So in this case, websites are like the data that we're working with. Flashcards are a very useful output. You use those to study, right? So just thinking in terms of that, where's the input, where's the output? Because RAG is simply just an element in the whole data journey of how you can convert something that's very like accessible or like just out there, and actually filtering it down into like a very valuable use case. Yeah. All right. Any questions in Google Form? I'm not sure. Just let me know if there were any. Maybe another few things that I could talk about could be, okay, let's talk a bit about prompt engineering. Prompt engineering is probably something that I think most of you guys have heard of. People say it's like a very like, I guess like hot job in terms of like, how prompt engineers are going to take over jobs and stuff. But prompt engineering is just simply a technique, which is basically what we're doing with RAGs here. I'm going to pull up the code. Actually, I'm going to pull up this slide instead. So this is, hopefully you can see that, it's that here. This is just like an example of a prompt. So this is AWS's explanation of how a good prompt should be formed. You'll give an introduction to the prompt, which is like, oh, this is a text from a restaurant review. and you put your entire piece of context in the middle, and then at the end, that's where you put your instruction. There's been a lot of research done on prompt engineering, like very in-depth research. There's problems such as insights and information in the middle of the context is likely to be forgotten or not used by AI. So it's actually good to place relevant stuff at the top and then at the bottom. That's why this is really good prompt construction here. What else was there? I also mentioned a bit about agents on how you can sort of like prompt the AI to search for certain use cases and actually just give you parameters instead of output. There's also, yeah, this might be a little bit in depth, but there's also different prompt engineering techniques known as like chain of thought prompting. And it's basically at the end of your AI prompt, you'll basically tell it to think in terms of steps. So it's actually generating step by step, and it's likely to use its own context in its own generation to support its following response, if that makes sense. So this is like things that people have researched that have tended to improve the quality of like responses at this stage, at the output generation stage. So I worked on something similar like this last year. I was trying to optimize like math calculations based off like a PDF. So it would be like a PDF of like, it was like for a company. It would just show you like, if you went to this country, you'd be granted this much money for like a business trip. So I was trying to get that and try to find the number of days in order to actually make the correct calculation. So by setting up an agent and telling it to think in terms of steps, it was outlining each step, and it was more likely to get the right number and the right day and calculate it together and produce the right answer. So it ran a lot longer, but it was more accurate. So that's sort of like the trade-offs that we have to think about as well. So like accuracy and sort of like the time it takes to run. But yeah, agents are very cool. I can give you a quick example of what I also did before.
Okay, I think we'll probably wrap up there.
Okay, I'll show this last slide though.
Okay, yeah. Ethan will stick around.
Yes.
Yes.
Link to these slides, by the way.
Yes, yes. Okay.
If you want them, and if you want to connect, you can connect on LinkedIn as well, and we can chat there. But yeah, I'll let you.
Leave this slide up for a few seconds.
Yes.
Okay. Everyone's got that?
Do we have a couple of slides with you?
I might have to do them.
Okay, it's all good. All right, you have a few more seconds of this. Yeah. All right. Everyone, could we please give a big round of applause for Ethan? Ethan is actually in his first year. He's a student here, first year, first semester. He's also part of Syncs, part of the Syncs team. So it's very impressive that everything is done and all that he knows at his age. I encourage you guys to come up and have a conversation with him, asking about his experiences and what you've learned today as well. Talk a bit about Syncs.